Okay, so we have here an interesting problem because some here fluids are flowing already. Here we have here a differential manometer. When we say differential, because it can only measure difference in pressure between sections A and section B. That's the idea, general idea. Here is used attached to a pipe shown. So attached to a pipe dani, and this pipe, there's flowing fluid inside it. But the analysis here is that the fluid here that moves in here is essentially static, therefore things can still be solved, essentially be solved. Calculate the pressure difference between points A and points B. Okay? Now, the idea here is we can use fluid statics even if there are part of the fluid that is moving, as long as this fluid here are not moving. So we can the equation still works in this part. Okay? And now siguro kaning nga part diri naga-move din sa babaw pero kaning daan is wala na naga-move. And this is made of usually this is oil of density 0.90 ang iyang specific gravity is mercury aning na ang mga values. Now, how do we solve this? Well, assume in this case we follow the normal thing that they do, that we could write even the equation starting from here, we move up. Okay, we move up, we move up, we move, then move horizontally, then there we just simply traces this one. Ang nilang balang nahitabo, no? Until we reach point B. Nga na ang case, move until we reach point B. And here, accept it as is, the fluid statics can still be used even if kana siya nag-move, because what we are measuring here is just actually static pressure. Okay? Now, so PA here, the pressure here is PA. So we have here PA. As you move up, what happens to the pressure? It will increase, right? Yes, it will. It will increase. No, the pressure will decrease then. If you move up, the pressure will decrease. So you subtract it by minus. Ilan mo na siya? Well, you move up taman sa diari, taman daani nga point. Pila mo ni nga height? We don't know that height yet, but we may call that height, let's say height y. Okay? We cool with that? Yes, we are. Okay, let's call that height. Eventually later we'll find out that that can be cancelled only. So it will be minus rho of the fluid, that's 900 times 9.8 times y. Okay? Now, we know here that the density, this is made of the same fluid, so the pressure here and the pressure here is just the same. Okay? And we move down by 100 millimeter. Okay, so the pressure will increase by, what's the fluid in here? The fluid is still oil, plus 900 minus 9.8 times 100 millimeter is zero point 0.1 meter. Okay, so the ane you move by that, move down, so the pressure increases. Also in here, see we're now in here. We know that as long as the fluid connectum dam is the same, nothing happens if you transfer to here. Makancel lang man ang pag-increase o pag-decrease. So we are now in here with no pressure changes. Now, we move up. Okay, we move up, so it simply traces that we move up to this point. Okay, the pressures now will decrease by how much? 13,600. That's density of mercury times 9.81. 9.81 times, pila mo na nga distance? That's 0.1. Okay? So, natadaan. Now, we know that if we're here and we simply traces the same fluid, tamandaan na nothing happens, right? No pressure changes. Pareho lang sila, kaya pareho sila level. Okay, so wala may tabo. And we move down to point B. Unsa nagali ang fluid nga nadani? Oil na ang fluid nga nagflow diani. So, we move down to fluid. This meaning the pressure increases by how much? Plus 900 times 9.81. Point B is, pila may distance ana? Kana nga distance, of course, pareho na sila nga distance ani. That's simply y. Y gihapon na siya, right? I think it's clear from the figure. So, here, times y. Simply, nag-cancel ang bali ang kaning duha ka points dani. Then, that is now equal to pressure at point B. So, yung ana lang, we start from PA with traces, curves, and we end at point B. Okay? And what we are looking for in this problem is really PA minus PB. So, simply, we group PA there. So, we say PA now minus PB will then be equal to kaning mga terms. Balik to sa PCAS, kanipod, balik sa PCAS. So, we have here simply negative 900 times 9.81 times 0.1 plus 13,600 times 9.81 times 0.1. Okay? And therefore, PA minus PB is equal to ang value ana ni 12.46 kilopascal. Okay? So that is our answer. So straightforward lang. Okay, that's it.